Hello, I'm going to say a little bit today about the observational challenges for monitoring global change at the limits of detectability. Now, this is motivated by discussions of the temporary slowdown in warming. This map shows near-surface temperature anomalies from the HADCRU T5 dataset. And you can see there are obvious gaps in coverage of the Arctic, the Antarctic and Southern Ocean, as well as parts of Africa and South America. If we fill these gaps in, as we have attempted to do in the HADCRU T5 analysis, you can see that the picture can appear quite different. In this case, the well-known hole at the North Pole is filled with strongly positive anomalies, and indeed, since around 2005, this leads to an increase in the estimated trends versus the unfilled dataset. Clearly, this has been important for understanding recent global trends. If we cycle through a few ensemble members, which are how we represent the uncertainty in the analysis, we can see that temperatures are not uniquely constrained, not just in the Arctic, but in other areas too. So what about these other areas? Well, for the Arctic, despite differences between datasets, as shown in this time series of Arctic average temperatures, the signal, be it from multi-decadal variability or the long-term trend, is much larger than the differences between datasets, which is a proxy for the uncertainty. For the Antarctic, on the other hand, not only are the differences between datasets larger relative to any interesting signals, but the record is also significantly shorter. There are no systematic measurements from the continent prior to 1958. This is also important for understanding uncertainty in global temperature change, particularly further back in time. Over Africa, we have somewhat similar issues. Here we show 4 maps of annual temperature anomalies for 2020 from 4 different datasets. It's clear that even in the modern period, there are important differences between datasets in the sparsely observed area in the centre of the continent. The sparse observations have related issues that compound the difficulty of accurately assessing average temperatures and their uncertainties. Sparse sampling and short records make it hard to quality control and homogenise the data, both of which activities rely on neighbour stations for their full effect. It's not just land that has issues. Over the oceans, changes in how sea surface temperatures were measured has left its imprint in the global temperature record. These plots show sea surface temperature anomalies for the globe and North Pacific for 2 subsets of data made by ships using buckets and engine room measurements. The unadjusted series, which we expect to diverge somewhat, as shown at the top. At the bottom, we have the adjusted series, and while the adjustments work at a global level, they bring the orange and blue lines closer together, there is significant residual uncertainty in the North Pacific, which is of course important for understanding decadal variability in the region. Chan and Hoybers have performed a more detailed analysis comparing the Atlantic and Pacific prior to the Second World War and find similar types of uncertainties. While the SST record is relatively well understood, recent papers have started to ask whether we should be using SST, or air temperatures over the oceans, in our estimates of global temperature. The difficulty here is that the adequacy of the monitoring network for SST is vastly superior to that of air temperature. These plots show the adequacy of the SST network for July 2007 on the left, and that of the marine air temperature network for the same month on the right. The latter is confined to well-travelled shipping routes and has no coverage at all in this month for larger areas of the southern hemisphere. Whatever problems we have using SST, these are compounded by using less well-measured and less well-understood marine air temperature data. So a summary and some potential solutions. Data gaps are of course an issue, and these can be partly remedied by digitisation and wider data sharing. As well as making datasets, we need to quantify uncertainties over multi-annual and decadal timescales as comprehensively as possible. Here, we need new methods and even whole new datasets the better to assess the structural uncertainty. We do already have a number of multiple datasets, and here we could benefit from systematic comparisons to understand the differences between them. Attempts have been made to combine global temperature estimates into a single usable dataset, and these could benefit perhaps by including the dataset creators in the process to get a more thoroughgoing view of the issues. Finally, it's important to provide all this in a way that's useful, usable, and in a way that gets it used by the users. And here we would of course welcome any feedback from users on the best way to do that. Thank you very much.